everything living on Earth is the result of evolution. Most often, it is a slow process. Sometimes it is instantaneous and brutal. Worlds disappear, and life begins a completely new game. Today, we take an incredible journey through the largest mass extinction events that completely changed the history of our planet. The biggest extinction events on Earth. Before extinction, there has to be life. So, how did it emerge? There is a classic hypothesis of chemical evolution. Organic molecules gradually accumulated on the young Earth, saturated with energy and reactions, and one day they learned to copy themselves. Most likely, this happened at hydrothermal vents at the bottom of the ocean. There, minerals create porous microchambers, and differences in temperature and chemical composition provide a constant energy source. Molecules collide, become more complex, and one day the system becomes alive. There is also the panspermia hypothesis. Perhaps primitive life arrived on Earth already formed, carried by meteorites and comets. And yet, the mystery of how the first cell emerged remains unsolved. However, researchers have determined the approximate time of the emergence of life on Earth. Let's go back 3.8 billion years, the early Archean. Here, a human being would not survive even a minute. The land consists of dark stone plains. The oceans are murky and rich in minerals. The sky is gray and smoky. There is practically no oxygen. There is no ozone layer. Ultraviolet rays freely hit the surface. And yet, it is here, at the bottom of warm, shallow water bodies, that life begins. For now, these are the simplest anaerobic cells. That is, cells that live without oxygen. Lightning initiates reactions. Volcanoes emit gases and heat, and ultraviolet rays strike from above. As a result, the ocean turns into a chemical broth of organic acids and hydrocarbons. The first cells get their energy from these organic compounds. And most importantly, they already know how to multiply and pass on inherited traits. And everything seemed fine back then, until there were simply too many cells. 2.3 billion years ago, Paleoproterozoic. The Earth still looks hostile, but something has changed. It is not yet obvious to the naked eye, but it is a serious change for cells. So what is going on? Colonies of simple anaerobic organisms are growing, and reserves of available organic matter, which served as food, are decreasing. The old model of survival no longer works, and those who have learned to obtain energy from sunlight gain an advantage. In the process, the cell transforms water and carbon dioxide into organic substances. It also produces oxygen, which is released into the environment. This is what is called photosynthesis. The first organisms on Earth to master this technique were probably cyanobacteria. This was an evolutionary breakthrough. Oxygen begins to accumulate in the atmosphere, completely changing the Earth. What's more, aerobic respiration turns out to be an energy cheat code. It provides the organism with about 18 times more energy than anaerobic methods. During the same period, some cells switch to autotrophy. They stop relying on pre-made nutrients and begin to produce it themselves from water, CO2, and dissolved materials. It would seem that everything would blossom, but no. These changes lead to an oxygen catastrophe. This is because oxygen was a deadly poison for the anaerobic life forms of that era, and from the moment there was more oxygen, many of them were doomed. up to 90% of all anaerobic organisms on the planet perish. This is the first mass extinction on Earth. Some anaerobic organisms take shelter. For example, they settle in the bottom sediments without free oxygen. While feeding there, many of them release methane. Others adapt to oxygen, thereby winning the metabolic jackpot. 1.8 billion years ago, the middle of the Proterozoic era, and for the following billion years or so, the planet remains relatively calm. It is at this time that a crucial event occurs. Organisms emerge that are no longer bacteria. These are eukaryotes, cells with a nucleus and a complex structure. And 1 billion years ago, the first photosynthetic eukaryotes appeared, early algae. Gradually, life becomes more sophisticated. Algae become more diverse, and stable multicellular forms appear. And now we move back 485 million years. The world still looks unfamiliar. Most of the modern continents are united into one supercontinent, Gondwana. The oceans are teeming with life. Brachiopods, conidants, mollusks, echinoderms, trilobites, sea sponges, and reef-building life forms have appeared. Plankton and graptolites drift in the water. The Great Ordovician Biodiversification Event, GOBI, takes place. During this time, the number of marine life forms doubles. It all seems too peaceful, doesn't it? Not exactly. 443 million years ago, the beginning of the Silurian period. Life on the planet is concentrated in the ocean, particularly in shallow coastal seas. These environments are warm and rich in food. And then, the climate suddenly gets colder. Glaciers spread across Gondwana. The ice traps water, and the ocean level drops. The coastal seas disappear, and marine ecosystems are ruined. This was the first wave of the Lome-1, Late Ordovician Mass Extinction Interval 1. As expected, the first to die out were species that lived in shallow coastal seas. These included many reef-building organisms and trilobites, marine arthropods. But those who lived in deep layers were lucky. The water there is more stable, and the cold conditions are more familiar. Plankton and graptolites, colonial marine organisms, continued to drift in water mass. And mobile cephalopods, primarily nautiloids, the ancestors of modern nautiluses, went deeper, deep enough to survive. This all most likely happened due to Gondwana's movement to colder latitudes. But the planet didn't even have time to catch its breath after the first wave of mass extinction. Just a couple of 100,000 years later comes the second wave of the Late Ordovician mass extinction, Lome-2. The climate swings in the opposite direction. The glaciers melt, the sea level rises. The melted ice waters disrupt the circulation of the oceans. They lose oxygen. Anoxia begins, the depletion of oxygen reserves in the water. Toxic compounds and metal ions accumulate in it. This time, even those who had survived the cold perished. The result is devastating. Up to 85% of marine species disappear. Is there any chance of recovery after such disasters? 438 million years ago, just 5 million years later, species diversity had already recovered to almost pre-extinction levels. The first fully terrestrial organisms appear, primarily fungi. Along with them, arthropods come ashore. First millipedes, and a little later, arachnids. And then another burst of life takes place. 419 million years ago, the Devonian period. The Devonian explosion happens. The Earth is finally becoming green. However, at first, plants do not exceed 1 foot in height. By the end of that era, there were already 100-feet-tall giant trees. Many insects appear. Vertebrates take a leap forward, becoming more complex and diverse. Impressive, right? But the main characters of the Devonian period are fish, sharks, jawless and jawed fish, and the great Devonian reef systems emerge. Cephalopods, such as ammonoids, evolve rapidly alongside them. But a sharp jump in biodiversity is always followed by a sharp decline. 372 million years ago, the Earth loses a huge number of life forms. The reason is unclear. One hypothesis suggests an asteroid strike. Its trace is the Siljan crater in Sweden. The Devonian extinction may have lasted from 500,000 to 25 million years. It is believed that this was not a single extinction, but a series of catastrophes. Two of the most destructive were the Kelwasser event 372 million years ago and the Hangenberg event 359 million years ago. The extinction primarily affected shallow warm seas, the most densely populated ecosystems. Sea sponges and corals suffered greatly. Cephalopods were particularly hard hit. Ammonites lost up to around 87% of their species. Vertebrates were also affected. Conidans declined sharply. And as usual, it was followed by a burst of life. Ironically, it was just as scary. 358 million years ago, the Carboniferous period. The world is green and rich in oxygen. Creatures that today would look like monsters from science fiction crawl and fly through the dense green forests. And no, these are not ancient dinosaurs as you might have thought. Here are dragonflies with a wingspan of up to 30 inches. And these are millipedes measuring about 6.5 feet. How about 5 feet long scorpions? Why did nature play such a joke? It's all about oxygen. Its content in the atmosphere reached 35% instead of the current 21%. This contributed to growth. Scary, isn't it? But the world of giants wouldn't last forever. 252 million years ago, the transition from the Permian to the Triassic period. The Earth is already recognizable. There are complex ecosystems on the green land, and animals have colonized the continents. And what happens next is an absolute devastation. The largest mass extinction in the history of the Earth begins. Many echinoderms and brachiopods, marine animals that look like bivalves, disappear from the oceans. Reefs collapse. Trilobites and many fish disappear. 81% of marine species and 70% of terrestrial vertebrate species die out. Insects were also affected. Virtually all giant species of the Carboniferous period disappeared. Why did this happen? The main cause of the Permian extinction is believed to be volcanic eruptions, which continued for 2 million years. Huge amounts of carbon dioxide were released into the atmosphere, causing global temperatures to rise. Species in the oceans began to suffocate. The consequences were apocalyptic. The planet lost most of its complex organisms. But again, mass extinction paves the way for new species. 225 million years ago, early Triassic period. The world still seems empty after the Permian disaster. Gradually, archosaurs, the ancestors of dinosaurs and crocodiles, begin to dominate. During this period, mammals quietly emerge, small nocturnal animals that survive in the shadows. New species, new life. What lies ahead? 201 million years ago, the Triassic-Jurassic extinction event begins. It lasts not millions of years, but around 10,000 years, a blink of an eye in Earth's history. The entire class of conidans disappears, and 23 to 34% of marine genera become extinct. On land, about 42% of quadrupeds perish. Most likely, this happens again due to active volcanic eruptions. A new force takes over the vacant world. 200 million years ago, the Jurassic period. This is the peak of dinosaur dominance. For the next 135 million years, they will dominate the land, the air, and the coastal areas. But even this era will prove to be temporary. 66 million years ago, the Cretaceous period. The world is teeming with dinosaurs, and nothing can threaten their survival. The Cretaceous Paleogene mass extinction event was sudden. The catastrophe wiped out 75% of animal species. Except for sea turtles and crocodiles, all quadrupeds weighing more than around 55 pounds died out. It seems that all dinosaurs disappeared. However, despite popular belief, some lines of smaller species survived, and these were birds. A kind of ice age begins. Photosynthesis in plants and plankton declines sharply. The oceans quickly become oxidized. But why did everything change in almost an instant? It was all because of the fall of a giant asteroid. In the 1970s, the Chicxulub crater was discovered on the Yucatan Peninsula with a diameter of more than 100 miles. This is the imprint of that impact. The asteroid strike triggered a series of terrible earthquakes with a magnitude of up to 11.2. The quakes are about 50 times stronger than any earthquake we know of. The planet shook so violently that volcanoes awoke and began to erupt. The demise of the dominant groups of the Cretaceous period left the world free. Mammals got a chance. They evolved and filled the ecological niches left by the dinosaurs. Extinction puts an end to the Cretaceous period, and with it to the entire Mesozoic era. The Cenozoic era begins, the era we are living in now. And as always, mortal danger is an opportunity for other species. Chicxulub paved the way for us and other mammals. And so far, we have spent millions of years without mass extinction. But what lies ahead?